All right, today we're going to talk about subtracting rationals. Okay, I know earlier in the week, or maybe just a while ago, you did adding rationals. All right, so I'm going to go pretty quick through this. If you need to go back into more detail, you can go back to the lesson on adding rationals. Okay, but basically the point of subtracting is we don't ever subtract. Okay, we always add, okay, by distributing the negative, okay? Shouldn't have put that. Okay, we're going to distribute the negative sign and turn it into a plus sign. Okay, so no different than what you did yesterday, except for we are going to say, instead of saying 4 minus 2, okay, or 4 over x minus 5 minus 2 over x plus 3, we're going to say that this is plus the negative version of that, okay? So just like yesterday, we need to find a common denominator, and then once we have that, we can combine like terms in the numerator and go from there. Okay, so x minus 5 and x plus 3 don't have anything in common, all right? So all I'm going to do is I'm going to multiply both of those by each other. Remember, we have to do the top and the bottom because that is x plus 3 over x plus 3, which is 1, and multiplying by 1 doesn't change the value. Okay, so this would be x minus 5 over x minus 5. Again, that is the identity method. Nothing is changing. Okay, so now if I go in to change this or to simplify this, my common denominator, my LCD, okay, I'm going to go ahead and write my LCD as x minus 3, x plus 3 times x minus 5. All right, now I'm going to distribute, okay? Distribute the 4 into both the x and the 3. That's going to become 4x plus 4 times 3 is 12. And then now I'm going to distribute this negative 2. Okay, remember I made it a negative 2 because it was subtraction. So negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. Okay, so now all there is left to do is to go ahead and combine my like terms in the numerator. All right, so 4x and negative 2x gives me 2x. 12 and 10 gives me 22 over x plus 3 times x minus 5. Now, you could factor out a 2 in the numerator, but I know if I factor out a 2 in the numerator, I'm going to put this over here to the side. It's going to be 2 times x plus 11. I'm okay with that answer also, but me, for my purposes, I know that x plus 11 is not going to cancel out with anything in the denominator, so to me, there's no point in going ahead and factoring that out, okay? So at least as far in my, as me in my class, I'm going to go ahead and say that that's an okay answer, understanding that if you put that in for that numerator, then that would be okay as well, okay? Or if you were to FOIL the denominator, that would be okay with me as well. All right? All right, moving on. Okay, the last two of the day, okay? First thing I do, I'm going to have to do an example 2 is factor the denominator in the first rational. Okay, now, whether you said, hey, this is difference of 2 squares and recognize that as factoring to x plus 1 and x minus 1, or you said use the x method saying, okay, 1 times negative 1 gave me negative 1 and 1 minus 1 gave me 0, which is my middle term, my b term. That'd be okay as well. Okay, that makes it pretty easy to recognize what my common factor would be. I don't have to do anything to my first rational, my common denominator, excuse me. I already have an x plus 1, so all I'm going to need to do is put an x minus 1 in the top and the bottom to the second rational. Now, don't forget, since this is a subtraction sign, all I want to do is distribute that negative. Okay, it's important to do that. You'll see why here in a second. The most common mistake here is probably to multiply positive 4 times negative 1 when I'm distributing here in a little bit. Okay, so my LCD is x plus 1, x minus 1. I don't have to do anything to my first rational in order, as far as changing it to write it down when I combine. Okay, now I am going to have to distribute my negative 4 times x and negative 4 times negative 1, which is positive 4. Probably the most common mistake, again, would be putting that plus 4 as a minus 4, forgetting to distribute the negative all the way through. Okay, so here we go. Those two can combine. I'm going to call that negative 2x plus 4, and I'm done. Okay. Now, you could write the numerator like this. If you factored out the negative 2, I'm not as worried about that just because I know x minus 2 is not going to cancel something out. Now, if this x minus 2 showed up in the top and the bottom somewhere, then we would have to simplify that further by canceling that out, like we did when we were multiplying and dividing. Okay. Excuse me. Last example. All right, 5x and x. Well, the common denominator is going to be 5. Or excuse me, 5x. So all I need to do to the second rational is multiply by 5. So if I multiply the top and the bottom by 5, I'm not changing the value of it. The only difference between adding and subtracting is I got to distribute that negative and make it a plus sign. All right, so LCD is 5x. X plus 1 is not going to change. Now I got to distribute my negative 5 times x is negative 5x. Negative 5 times negative 3 is plus 15. All right, combine my like terms in the numerator. I get negative 4x, and 1 plus 15 makes 16. Okay? And lastly, this is good enough for me, but in some classes, or you may see the answer written like this in the numerator. Okay, but the negative 4 and the 5 don't reduce in this case, so I'm okay with just that being the answer. Okay, and right above it, you can substitute that in for the numerator if you were to factor out the common factor. Okay, all right, that's it for the examples on subtracting rationals. I'll go ahead and plug in the answer key up into Google Classroom for the assignment later on this week.